Imagine stepping onto an alien planet. You're wearing a spacesuit, but within seconds, 5 different things begin killing you. The gravity crushes your bones, the atmosphere ignites your suit, the wind tears you apart at 5,000 miles per hour, the temperature melts your visor, and the rain, made of molten glass, shreds whatever's left. The question isn't if you'll die, it's which method reaches you first. And the answer might surprise you, because in space, death has a hierarchy. Let's start with one of the most famous death worlds in the galaxy, HD 189733b, a beautiful deep blue planet. From a distance, it looks like Earth, but step onto its surface and you'd experience something worse than any nightmare. The temperature, 1700 degrees Fahrenheit, 930 degrees Celsius, hot enough to melt lead. Your spacesuit would begin degrading immediately, but you wouldn't die from heat first. The wind, 5,400 miles per hour, 7 times the speed of sound. Hurricanes on Earth max out around 200 miles per hour. This wind would rip you apart like tissue paper. But even that's not what kills you first. The rain, molten silicate glass. The atmosphere is filled with silicon particles. These particles condense into molten glass droplets, and they fall sideways, carried by supersonic winds. Imagine being sandblasted with glass, moving at Mach 7. Your suit tears open in milliseconds. Your body is shredded. You're dead in under 3 seconds. Cause of death? Kinetic trauma from glass shrapnel rain. KELT 9b, the molecule-destroying inferno. Now let's visit the hottest planet ever discovered, KELT 9b. Surface temperature, 7,800 degrees Fahrenheit, 4,300 degrees Celsius. Hotter than most stars. Hot enough to vaporize iron. Here's what happens when you arrive. 0.001 seconds. Your spacesuit begins sublimating, turning directly from solid to gas. 0.01 seconds, the molecules in your body start breaking apart. Not burning, not melting, disintegrating at the molecular level. Water molecules split into hydrogen and oxygen. Organic compounds decompose instantly. You don't feel pain. You don't feel anything. Your nervous system ceases to exist before the signal reaches your brain. 0.1 seconds. You're a cloud of atoms. Cause of death? Molecular dissociation. Time to death, less than 0.1 seconds. This is the fastest death on any known planet. You wouldn't even know you died. CoRoT 7b, the lava rain planet. CoRoT 7b gives you slightly more time to suffer. Surface temperature, 4,200 degrees Fahrenheit, 2,300 degrees Celsius. The planet is tidally locked. One side always faces its star. That side is a sea of molten rock. The other side is frozen solid. And in between, a narrow twilight zone where rock evaporates, forms clouds, and rains back down as molten lava. Here's your death timeline. 0 seconds. You land on the surface. 1 second. The ground beneath you is liquid. You sink. The heat penetrates your suit. 3 seconds. Your suit's cooling system fails. Internal temperature skyrockets. 5 seconds. Your skin begins blistering. 10 seconds, you pass out from heat exhaustion and hyperthermia. 15 seconds, your organs shut down. 20 seconds, you're dead. But the planet isn't done. Your body slowly sinks into the lava ocean. Over the next hour, you're fully consumed. Cause of death? Thermal shock and organ failure. Time to death? 15 to 20 seconds. Slower than KELT 9b, but far more agonizing. The radiation nightmare PSR B1257 plus 2c. Now let's visit a planet orbiting a pulsar, PSR B1257 plus 2c. Pulsars are the corpses of massive stars. They spin hundreds of times per second, and they emit lethal radiation. X-rays, gamma rays, particle beams. Standing on this planet, you'd be bathed in radiation equivalent to being inside a nuclear reactor. Here's what happens. 0 seconds. You're exposed to intense electromagnetic radiation. 5 seconds, your DNA begins breaking apart. 10 seconds. Cells start dying en masse. 30 seconds, acute radiation syndrome kicks in. Nausea, vomiting, disorientation. 2 minutes, you collapse. 5 minutes, cerebral edema. Your brain swells. 10 minutes, you're dead. But here's the horror. Your body would remain lethally radioactive for years. Cause of death? Acute radiation poisoning. Time to death? 5 to 10 minutes. WASP-7b, the Iron Rain Planet. Let's talk about a planet where it rains liquid iron. WASP-7b. This planet is tidally locked. The day side is so hot that iron vaporizes into the atmosphere. Then wind carries the iron vapor to the cooler night side, where it condenses and falls as molten metal rain. You land on the night side. Here's your timeline. 0 seconds. The air temperature is 2,400 degrees Fahrenheit. Cooler than the day side, but still hotter than molten lava. 5 seconds. Droplets of liquid iron begin falling around you. Each one is 2,800 degrees Fahrenheit. 10 seconds. A droplet hits your suit. It burns through. 15 seconds. More droplets hit. Your suit fails. 20 seconds. You're being pelted by molten metal. 30 seconds. You collapse. 45 seconds. You're dead. Cause of death? Thermal burns and asphyxiation. Time to death? 30 to 45 seconds. The gravity death. Super-Earths. Finally, let's talk about super-Earths, planets with 5 to 10 times Earth's mass. The gravity on these worlds is crushing. If Earth's gravity is 1g, a super-Earth might be 5g or more. Here's what that does to you. Immediately, you feel 5 times heavier. If you weigh 150 pounds on Earth, you now weigh 750 pounds. 10 seconds, your legs buckle. 20 seconds, you collapse under your own weight. 1 minute, blood pools in your lower body. Your heart struggles to pump against the gravity. 3 minutes, you lose consciousness. 5 minutes, cardiac arrest. Cause of death? Gravitational cardiovascular failure. Time to death? 3 to 5 minutes. Not the fastest, but one of the most inevitable. The death hierarchy. So here's the ranking. First place, the fastest death. KELT 9b, 0.1 seconds, molecular destruction. Second place, HD 189733b, 3 seconds, glass rain shrapnel. Third place, CoRoT 7b, 15 seconds, lava heat. Fourth place, WASP 7b, 30 seconds, iron rain burns. Fifth place, super-Earths, 3 minutes, gravity crush. Sixth place, PSR B1257 plus 2C, 5 minutes, radiation. The universe is not designed for human survival. We are fragile, and space is hostile. But understanding how these planets kill us teaches us what we need to survive, because one day we'll need that knowledge.